Yes. So in previous session, we talked about something related to macro, correct? And we said like if a macro is there, then it involves two different processes. One is macro definition phase and other one is macro expansion phase. Now, if we recall correctly, more or we said like in macro expansion phase, macro definition phase, we would be making use of two different data structures. One is macro name table, other is macro definition table. So these would be used to keep the definition, and in expansion phase, it would be simply a find and replace kind of stuff. Correct. Now, like this find and replace would be like if you see, you are going through one course called theory of computation. Okay, at least MSc computer science students and those from scientific computing and who did BSc CS, they must have learned one course called as theory of computer science or theory of computation. Now you must have learned something called as Turing machine, correct? And that's what is happening. Only it would be some intelligent kind of Turing machine which would be doing this find and replace explicitly in a better manner. Now, why I'm saying that it is an intelligent find and replace, it is because like whenever we see the parameters used and when expansion is to be done, at that time every parameter used for passing purpose is to be replaced based on its position, and that's what makes it different than the procedure. One other aspect. Second thing is like when you talk about a procedure or a function, rather when a function call is given, at that time like it would be linked altogether. Now how the linking probably can be done, let me show you with an example. Let us say suppose you have this procedure with you. Okay, so let me say for example mark this. Okay, and we have these are the statements. Say for example each line or each box represents say a statement. So let us make it this way. Fine. Now here you assume that there's a function call. Now what happens is it gives a call to this function. Okay, and suppose this is the function. Now what happens when the call is given? Ultimately, what we are going to do exactly is it is going to say pass control from here to this first line. Correct. And secondly, the call when it completes the execution. Okay, when the execution is done, at that time it will be going back again to this place. Okay, so we are assuming that this is X call and this is body of X. And this is what happens in say a function. Correct. Now in turn, suppose this function again gives a call to another function or another two functions. Say this is one and say this is two. Let us make it different. Okay, now suppose like similarly, if I follow the similar kind of methodology, this call say from here, okay, to this line, and similarly from here to this line. Okay, from this line, like I'm assuming that this second statement is a call which is getting executed. Now, like when execution is done, it should return over here. On the similar line, when function call at the other function is done, ultimately it would be coming back and executing it or returning back over here after the last line. Now, when we see this kind of structure rather for the functions, when the function calls are to be executed, we said that like this return address should be preserved. Apart from it, values of the global or local, whatever, depending upon how the variables are used, it should be preserved. Now, suppose this is happening with respect to the functions or procedures, but when it becomes a macro. Say for example, let us say this is my macro. This is my code, correct? And in between, I saw this call to macro X. Correct. So 1, 2, 3, 4, 5, 6 lines. Correct. So what happens is like we will add, say we will replace this by this, and remaining would be 4. This 4 would be there, which was earlier. Correct. So this is how the macro would be doing. So what happens is here the file size would be compact with assumption that these are linked through the libraries or these are executed at runtime or linked together by making use of instruction pointer. And this happens in memory that way, no matter which programming language you're using, whenever it is a function or a procedure. But when we are talking about a macro, ultimately, the macro call is replaced by its definition with appropriate intelligent replacement with respect to its parameters and few other information if at all necessary. And that's how the macro, like this would never be kept in memory later, like when expansion is done. Correct. So when expansion is done, this would not be kept at all anywhere. Then where exactly it goes? This definitely is not found anywhere because this is not necessary to be stored at all at later point of time. Right? Because this is already added as a part of the expansion phase. Now what happens if I talk about the code that is generated after these calls are executed, this would be a single executable. Here it would be a single executable, but before creating executable, size of earlier code would be combined along with the source code that is there. In this case, this source code is for this function call X is not added. It is only given a reference call and information in respect of that function is kept over here. But with macro, it doesn't happen that way. Correct. Now let me show you like if what happens if I give the same name as my instruction name for the macro. Fine. So let me show you that stuff. Now eventually what happens is like while I started writing a macro, so percent macro mov 2 or okay 3, okay, then add ex comma percent 1, add, let us make xor ex comma ex, add ex comma percent 1, add ex comma percent 2, move percent 3 comma ex, and then say I say end macro. Fine. Now let me write my code. Section dot text global main move 10 20 edi. Fine. Let us use this. Move ex comma 20, move ex comma 30 comma edx. Okay, now I'm using this. So which among these are macro and which among these are instructions? Okay, so let us try assembling this. So let us see this code one more time for your reference purpose. See this code. We have a macro named mov. So I'm using move this as an instruction. This is my macro name. So here as an user or what is visible to us, we can say this is a macro call, this is a macro call, and this is an instruction. Now let us try to see what happens there. So if I try to, sorry, elf dash e. Okay, now let us see where the change is. So this was XOR. Okay. So less 30 08 21. So this was like move 1020 EDI. So it started with XOR these four. So let us see. This was your macro. These were the four. Correct? You can compare this. So this EDI came into picture. Now there was an instruction called move x comma 20. So this instruction came into picture over here. And then this. Now you will never see a move along with three parameters over here in the expansion after the expansion because it was not mandatory. Now I specifically made maybe macro name as move and kept three arguments. What happens if it contains only two? Okay, now let us do this. So let us copy these equis. So let us make it 0, 1. So Emacs these equis 0, 1 dot asm. Now let me make the change as 2 and I will make it as ESI. So I will remove this. I will remove this. Fine. So I have three instructions. Now, as per our understanding, so if I try to assemble this, it should give an error, correct? 10, 20. Fine. So let us see what happens. So let me show you one more time the code. Less 38 21 01.asm. See this code. So we have a macro with two parameters. There's the XOR. So this is again a macro. So is it going to execute a macro call? We have to verify that. So will this be a macro or will this be a move instruction? So will this be move instruction? This one also move instruction. This one also move instruction, or all these four moves are treated as macros. So let us try to see the expansion. Now see this code. So first we got 1020. Correct. So XOR, you can see XOR is occurring four times. Sorry, three times. XOR, XOR, and XOR. So as we have three macros, so we treated all three as macro calls. Now you may say this was only my macro call, but this was not. But it doesn't really worry about this. It doesn't really worry about this. The reason behind, say, whenever you are acting as only a find and replace, it never worries about what happens there. Now there used to be one error in Notepad editor on Windows. Those who are having Windows 8 or maybe even Windows XP on their laptops can verify this. Now I am showing that part to you. Now suppose let me pick say these lines. So I want to repeat LIN K. Sorry, replace LIN with LIN K. Now suppose if I replace this LIN by LINK, again there would be LIN. Correct? So am I going to write that respectively? So let me start from here, first location. So what happened wherever LIN is, it added it, correct? Here, here, here. Earlier what used to happen is like, suppose I press Ctrl Z, okay. Now I got the original one and now suppose if I am here at this location and I am firing the same command. So now you will see that it replaced all. But earlier, because this was my Windows 10 version and the error was recovered of that notepad, which a user used to face with respect to that is find and replace. What it used to do is it used to replace, like if it is here, it used to replace it here only. It never used to go back above. Correct. So we need to always say find where. Say for example, if I write Control F, you will see this up and down. They kept it here, like whether I have to search up or whether I have to search down. So it is from the point where the cursor is. So if my cursor is here and if I try to search this, it is showing this, but next it stops. Earlier what it used to do, it used to go back at the top and it used to start from line number 1. So now when you are talking about your Turing machine, okay, ultimately there comes a question whether is it going to be a limited one or it is going to be unlimited one. So like it may not halt at all. You must have heard of something called a halting problem. When should it halt? When should it terminate? If it never terminates, then it should be in recursive mode. It will never stop. If it never stops, then you cannot really control the code. Then sometimes we use signals like control C or control break kind of stuff in Windows, or even sometimes in Linux. Our basic option probably might be control D. Suppose nothing gets terminated. Correct. Now that is the reason why this error was corrected by Windows later. Correct. So like whenever you are working with this, it never really worries because it doesn't know whether move is instruction or not. It only knows what was told to me, find this. What I am supposed to do, replace it by this. Whatever I found, replace it by this. But my replacement is now intelligent replacement. Now, for example, now you may see like what I did was I changed every link or LIN as LINK, correct? But I want to control that in the some way, like wherever linking is, only that linking should be changed. Linker should not be affected. Now, if you see, even otherwise, if I am replacing linker only with capital to be L, say for example, let me try to replace this. So let us say LIN. So control H. So let me take LIN capital and then I am saying LINK. Now what it should replace? So let me start here. So I will go one by one. So find next. So it is getting this, but actually eventually if you see, I wrote LIN. Correct, but my L was capital. Then it added this facility tool at the later stage, like, OK, you should match the case. So wherever you see this, suppose if you start from here, you see this, it will skip this because you said match case. So same thing that's what it becomes let some stage it would be intelligent replacement. But again, you have parameters to control over. Now what happens wrap around probably might be what you have LI and next line contains N. Then whether I am going to consider that as an LIN word or what. Right. So somewhere we saw dash. Let's see. Yeah, this compiler schedule, for example, this dash came into picture. Now this dash was in respect of like it is a continued word. It is in continuation to next line. Correct. So we used to we generally use this, but how the system will know this? System should be told. You will identify this. That's what I said. If at all you require this macro expansion phase is intelligent expansion or intelligent replacement, find and replace. So think of like you can try writing those who know Turing machine very well. Why not replace A? Suppose your string contains only A's. OK, A raised to N. Your string is A raised to N. I want occurrence of every A to be replaced by 2 A's. So what would be output of your code? So if you have say 4 A's for a while, how many A's you expect as an output? What you want? There would be a string. OK, with all A's with A raised to N. So N can be greater than 0. So if I want replace every A by double A, what should be my output? So whether you expect 1, 2, 3, 4, or you will go on. So this one would be output or something else. You decide this. What should I do? Whether I should go with my first option like this, or I should come up with something which is not matching with this A, whatever the answer that I was expecting rather. So what do you think? What would be your input in this case? What will you say if at all I have one A, set of A's given, OK, in as an a string. So every occurrence of A should be replaced by 2 A's. So what should be your output? So should it be 8 A's or should it be something else? Yes, please. Am I audible?
Yes, sir.
Okay, so what should be the output now? Think
Sir,
was
8.
8A should be the proper output. Is it? Everyone agrees with this? You can raise your hands if you agree. Or do you think every occurrence of A should be replaced? Because you were told what? Each occurrence of A should be replaced by 2 A's. So is it only 4 A's, or I should go back and check back and forth and keep replacing it by. So it will not be solved problem, correct? It would be unsolved problem. It will keep executed every time, and we don't want that thing to happen rather. Correct? We don't want that thing to happen rather. Now, if it is not going to happen, then how exactly we are going to work out this way? Because like in our example, when I said that, sorry, let me show you here. Let me go back to my Linux. Okay, now let us see this. What happens if my macro itself contains a call? Correct? So let us say I'm considering a case. Maybe it may or may not be true rather. Suppose my macro name is move1. This is move1. Okay, and I want this move1. Now what should it happen? What it should do? So whether should it add these 3 lines first and then again these 3 lines here. So whether you want 6 lines or whether you want 3 lines, and in assembly time this should give an error. What is your opinion? See this code. I have move1 declared. So I am calling a macro inside a macro with same name, because this would be a macro call, correct? So what should I do? Okay, this is one case. So let me write another one. Say percent macro abc1 move here edi comma %1 percent end macro and move1 edi comma 20, and here I am calling abc and 10. Now see this case. What I'm doing, I'm calling macro abc with macro parameters to be 1. I'm calling this abc here with 10. So edi would be containing 10. Now I should get call to this. So let us try to see. First of all, let me put comment over here for our understanding. Okay, so I'm considering that in a macro I am calling another macro. What happens if I call macro inside a macro with another definition? Okay, so let us try to assume. Sorry. Yeah. So if you see, my macro got expanded. My original code was this. My original code was this. Now see the expansion. What it did, it got ABC 10. So it got ABC 10. So XOR. So it got ABC 10. So it is here. Move EDI comma 10. So that's what it added. Now it got move EDI comma 20. So that move EDI comma 20 move 1 was added by these 3. So what was the last instruction? It was add EX comma %2. So %2 in this case was 20. So that's why this 20 came into picture. Correct. And then your macro was ended, and then you have move EX comma 20 and move EX comma 30 done. So it is permitting this kind of expansion. But what happens if I have a macro call like this? Suppose let me remove this now. Let me go here. Let me assemble this. This was our code. So it got this ABC 10. So it added it here and you are getting called this EDI comma 10 and your code was added. XOR AX EX. So it is not replacing this. Now it kept it as it is. This move one. That means what? Number of levels when the expansion is, you cannot call a macro inside a macro when both the macro names are having same name. Only permitted thing would be what? It would be permitted to call a macro inside a macro if macro name that you are defining and a macro call you are calling are not same. Then only it is good or it will be permitting this in as an a case sample case for NASM. But when it is not with NASM, ultimately other assemblers can provide you recursion as well permitted. So this is kind of recursion, correct? But how exactly you are going to break this recursion? Because whenever there is a recursion involved, you definitely require some mechanism to break the recursion. Stack also would be involved in the recursion space. And this would be one complicated issue rather. And that is the reason why very few macro assemblers, rather, when I say very few, almost none of them provide this recursion. If at all it is there, then this process is really complicated. And that's what is discussed probably in the book rather. You can see if you go to that particular book of ASL.pdf, which I shared with you, the book for assembler and loader. It talks about those days, like how exactly you are going to really sort out or work with the macro when it contains a recursion. This kind of recursion, if it is a function, like this move one is function name and this one move one is also function name. Here it is definition, here it is a call. Then it is good. In that case, you have to always know what would be the terminating condition. Here, how will you add that? So that would be an additional feature that a macro should support. So NASM doesn't support recursive calls. If I conclude this, but can I say this ultimately? I don't know. How exactly we are going to verify this? So we already verified like whether a macro permits you. Sorry, the assembler permits you the recursive call or not. Any question with this?
No, sir.
Okay, now suppose if you want to support this same thing. Okay, what do you think? What would be needed for this case? What would be needed if at all we expect this to work, this recursion, if it is to be supported, then how exactly we can do this? So what they
We
did
can add
is,
a break condition.
okay, you can have a break condition, but again it needs to keep this information. Whenever recursion is, it makes use of stack, correct? How will you make use of stack in this case? Break condition is fine, but that you are not executing anything like break condition. Na? You are not executing. Break condition would be when if you are executing this code, you are only doing what? Find and replace. So this macro keyword doesn't help us to work out this recursive macro. So what happens is like macro NASM added a few more directives. Okay, and if you see the comment window rather, I am adding those few directives. Oh, sorry, I don't think it is visible. So let me go to. Let me delete that because I don't think I don't know how the colors are added. Yeah. Okay, now you see this R macro. They added R macro. Again, there's a limit that it is provided. You can see this, correct? Can you see the limit? It provided the limit for how much macro thing would be there. Correct. So R macro would be for recursive macro, which can be called arbitrarily deep really high limit like 2 raised to 20 set to catch infinite loops. Okay, there can be IR macro too, which is case insensitive, like I macro. Correct. So like what you require there, if at all you want a support to be added for your assembler, macro assembler to handle recursive macros, then you require another directives. These regular directives used by you would not work like this percent macro. Is that fine? Now execution of R macro and execution of percent macro would be different. When I said execution, I mean in process execution perspective. What will happen at the time of recursive macro or recursion? We definitely can try it, but our target is not to work with this. Probably if we take an elective next semester, we will be working with this R macro. Remind me that time, those who would be taking the course. But this really is a kind of challenging task rather to come up with such kind of supports, because assemblers also do want to put their existence in front of the programmers, because every programmer really always talks about a compiler. Correct, but this assembler plays an important role because it is the only translator which is close to your architecture. Your compiler may be, but compiler always have to take help of an object code or some form of the code, what in Java you call as intermediate code. Correct? So in Java, you don't call it intermediate, but what you call as bytecode. You must have heard, na, bytecode. To execute that bytecode, you require something called as a Java virtual machine. So what exactly we are doing? So what are the code, like for example, suppose you design your own assembler. Now if you want to execute your code, then that code should be understood by something. And that's what, like those who did bachelor's probably from, I know basically 2 universities where this kind of assignment is added with their bachelor's syllabus in systems programming called as SMAC. Oh, SMACO, SMACO. Rohit, you must have implemented SMACO, correct? In your bachelor's?
Yes, sir.
Okay.
Smack zero, we call
Yeah,
it.
the SMACO, that was small computer, which was kind of simulator, which will understand our target, our instruction. Correct? Okay, any questions? Yes, any questions? Okay, yes, macro क्या होता है? Like let us try to listen from some of the people's, like okay, let us start with Rohit only. Rohit, can you please more light on, can you put more light on what exactly you used to do with that SMACO code?
I don't remember it much, but it was more of like move instructions were there.
Yeah, so you are generating an object code from your assembler, correct? And
Yeah.
that object code used to be executed in some environment. That's what you call a small computer or SMACO, correct? Which was
Yeah.
not having any kind of relation with Intel or any other board or any other instruction set. It was a simulator kind of. So can we call JVM as a kind of simulator? Java virtual machine as similar. What it is doing? See, can you read a bytecode? Can you see the bytecode in a text mode? Those having Java compiler installed on your laptops can try this. Try to display it by say type using type or cat, or try to open it with notepad. it would be somewhat similar to what exactly you do see like this. Okay, let me go here. Oh, sorry. Okay, so let us go back to, because that move one would be problem. Okay. Okay, here also. So they are warning. So let us not much worry about. So if I say cat 3821.0. So if I display this, now see how my code is displayed. I cannot see this code, correct? Even if I write using less. Because this is an encoded form. So it says, okay, it is a encoded form. You cannot read. But my linker knows what exactly this is. It is because the file format is specified as ELF. Okay, so if I write file 31 8 38 21.0. Sorry. काय झालं? Yeah, sorry. There was some kind of mistake I made. Yeah, .0 I wrote. Okay, .o. So it says ELF 32-bit LSB relocatable. That means it is containing some information that it tells my linker can understand. Yes, I can understand that it is this format. That's why it continues generating an executable for it. Otherwise, it will throw an error ultimately. Suppose let us go with nasm dash hf. Okay, so let me write nasm. Instead of this felf, I will write obj. Okay, ls dash ltr. So if I write this obj, now you will see it is different thing. It is not the same one. So if I try to even display obj dump dash d 3821.o, this file would be shown. But if I write obj, then it says file format not recognized. And even if I try with file, let us see whether it understands it. It assumes that it is an data. It doesn't care that it is an object file format. It considered it because when we displayed this content using this can be treated as data. Why not? That's what it is saying. And if I try to show the same thing with respect to .o, contents are different. You can significantly see the difference. Right? So if I want my linker to understand this, then it should be in the same format. Now suppose suppose I start speaking into my own language, which we generally use probably at home. I cannot guarantee that you all would be uh, getting what exactly I'm trying to tell, because it is in the language which cannot be understood by you. It is in the format which cannot be understood by you. Then how exactly we are going to work with? Similarly, let us see ls star dot pdf. Okay, star dot. Now suppose if I try to open this with Emacs, let me first show you file AU. It said this is audio file with ID3 version, correct? So it identified that file format. Now suppose if I try to open this same file with say gedit. Now let us see how it displays it. So first question would be, will it open? So it seems it tried opening this. It is working on it. My machine is really working on very hard rather to display. Then it says your text editor is not responding. You may choose to wait for a short. You say wait for a while. It will go on because it cannot read what the contents are. So same thing may happen probably. And if sometimes suppose if it can read few characters, it may display probably the things to you, but it is not guaranteed even because it exactly knows what to read and what not to read. Now I can terminate this by say signal. So if I'm trying to delete this, it is not working. Right? Terminate the command. It is not working. It actually my machine is not responding at all in such a case. So I will say force quit now. So it got killed. The thing behind is like whatever the file that I tried opening with some particular program, that program was not expecting this kind of file to be given as an input. So whenever we do talk about a linker knows what kind of inputs or what kind of input file should be given to me so that I can translate the code explicitly or I can generate an executable explicitly from the available files, object files, which are to be linked. And that's what like if suppose if I try to open some file which I am saying that it is a byte code, your JVM can understand whether it is byte code or not. If it is not in the format, then it suddenly will throw you an error. This is not the program that I was expecting. Same thing may be true for every other some kind of system program which would be doing this task for you. What other way? Like it could be a linker, it could be a loader, it could be anything. If your executable, like suppose, let us say ls, let us go back to cd. So let me say like this. So for example, if I say mv xampp.obj to a.out. Now I have given a.out as name. So in my view, this a.out is what? According to my understanding, a.out is what? A.out is an executable. But is it really an executable? So I went and checked with file command and it says it looks a file which is a common object file format. COF. What you call it as a platform independent kind of stuff. Okay, it may not be the same, but on AMD 64 it is a COF object file. Okay, what are the executable that I got, or what are the file name I replaced with, renamed with? But if I try to execute it like this, say for example, it will not work. Even I write this, it doesn't understand what is it. I cannot execute this because it is not the format which my bash can understand. Why I said bash? Because what are the program that is running here where my cursor is? Say for example, if I write ls dash l pipe less. Say for example, I'm displaying this and let me go here. Let me write ps dash a. Okay, with less. So if I try to see, this is my another terminal. Okay, and if I try to check rather with EJH, which is displaying a tree. Process tree you must have heard, na? Now see, let us see this where exactly our bash is. Bash is the shell which we are using for our code, where we wrote that ls. See here. On here we are using this current terminal. We are using this bash ps less. We are using ps and less. And if I see rather, suppose let me terminate this. If I go here, it should show this 4511 as bash only. Go below. So let us see whether can we get bash somewhere. Yeah, see 4511. There is no child available there with this bash. So this bash is your command shell, and that command shell could not understand what exactly you are trying to do. But suppose $gcc, if I write this dot slash a dot out now, it can understand. It understood this, but when I tried doing this, that obj file, it couldn't, because it was not meant for that kind of file. So these file formats really play an important role for every translator. What kind of file format it is going to support. So that's what I tried showing you. Like for example, NASM, if you write HF, it shows these all file formats it can generate the code in. And we are using mainly this. So if you write ELF, it takes ELF32. You can see this ELF, short name for ELF32. No need to write ELF32 at all directly. Even if you write ELF, it works. Fine. Okay. Any question till this? Now our next, like I hope you must have tried understanding now when we say bash, the byte code generated for some languages like Java. That byte code certainly means what? It is kind of object code only. Now you build an environment where that code can be understood by your linker. Now the kind of linking and execution environment is set there through that JVM, Java Virtual Machine, where your code gets executed. Some kind of object code. So some kind of object code. It may not be at all executable. It would be made executable only because of JVM. If you don't install JVM and if you try to load the bytecode, it will never get understood by your system at all, because your system doesn't understand what that bytecode means. So maybe try finding out what are the contents of bytecode, just for curiosity purpose. Okay, contents of bytecode. What are the contents of bytecode? You can try finding out it. Right. It will tell you like some kind of information is added in that code. Some kind of information which would be kind of an instructions used by your JVM at the execution point of time. So in general, I can say that the bytecode which is generated by Java is somewhat similar to an assembler which is representing your C++ code or C code rather. Is that fine? Any query, question, please? So in next session, our target would be what? Suppose if I give like for a while, suppose when I generate suppose a 32-bit code, ELF 32, an object code. Okay, I can see that for my object code, a symbol table is built. Okay, so I can see this with readlf2. This is my symbol table. So symbol table would be created. Now suppose if I have two object codes which are to be linked together. Now let us go in the similar fashion. ls-ltr star dot asm. So say I say nasm dash plf 32 intro 1 pass dot asm. Now suppose if I see this as well. Suppose this is one symbol table and let us say this is some another symbol table. Now eventually here we have two mains. So when two symbol tables are to be combined, entry should be 1. So this would not be permitted to link. So if I try to write say for example dash m32, if I try to link both the codes, let us see what happens. Dot o and intro one pass dot o. It should throw an error about multiple definition of main, the way we saw earlier with the symbols, because main is also here, main is also there. So only one occurrence of main should be there. But suppose, like if at all I have been given two different object codes, and if they are to be linked together, what exactly I should do at the time of linking? Okay, so this is what we'll be discussing in the next session. Fine. Any question at this time?